Okay, this is the 2.5 day tube notes. Now, most of you have done this in class and probably won't read this, but for those of you that have been gone, here's just a way for you to kind of see me work through it if you need it. So, if I have a bullet that's fired into the air with an initial velocity of 1,800 feet per second at an angle of 60 degrees from the horizontal, all that means is here's my horizontal. It's getting fired 60 degrees up. And then how fast is this guy or this bullet going? If I'm firing it in the air, this is the distance it goes, 1,800 feet per second. And what I want to know is find the horizontal and vertical vectors. All that means is I want to find the horizontal and the vertical to where this bullet will be after however long you want it to be. Basically, I want to know how fast it's going for velocity. So, horizontal is X, your vertical one's Y. And you now have a right angle because it's kind of straight up and down. So now you just do your simple trig functions. I have the hypotenuse. So if I want to find my horizontal first, my adjacent and hypotenuse, I need cosine. So cosine 60 degrees is x over 1,800. And if I multiply 1,800 to both sides, that's going to give you 900 feet per second. Okay? So that's how fast it would be going in the horizontal direction. And then the vertical direction, it's the same process except I now have opposite over hypotenuse. Opposite hypotenuse, that means it's so in the SOHCAHTOA. So it's going to be sine of 60 degrees equals y over 1,800. Multiply 1,800 to both sides and you're going to get y equals, and it's actually a pretty big number. I think it's 1,558.84 feet per second. So it's actually going to travel faster going up than it is going straight east, but in the end you probably should expect that because the 60-degree angle is farther than your middle of the road quadrant 1. It is farther up, farther towards the 90-degree angle or facing more up. So in my mind that makes more sense that it will travel faster going in the up direction. Alright, so let's go back to a plane problem. If I say a plane flies for 3 hours, 230 kilograms per hour, or kilometers per hour, oh my goodness, on a course of 215 degrees. Okay, we have to think about what's course again. If I say a course, that means you start from due north, and it's 215 in the clockwise direction, so 90, 180, and a little bit farther, so I'm actually going this way. Okay? So 180 is to straight down, which means this little angle right here would be, to get 215 is what, 35 degrees farther. Okay, so 180 and 35 gets me to that 215 degrees total. Alright, now 3 hours at 230 kilometers per hour. How far did we actually go? That's what, 690 kilometers. So this distance from where I started to where I ended is 690 kilometers. And what I need to try and figure out is how far west and how far south did I go. So from my start, due west, due south. That gives me a right angle. Alright, so in order to kind of use this, I need to find this angle inside. Well, if I know I went 215, you can think about it multiple ways. 215 plus what gets me to 270? Or this guy in here is a 90-degree angle, so I went 35 degrees past the 180. How much farther do I need to go to get to 90? In either case, it's 55 degrees is that angle inside. However, you can kind of visualize that. Now it becomes pretty simple to find your south direction and your west direction and how far you actually traveled. Okay? So in order to do that now, I'm going to do the south direction first, arguably speaking. So it's the opposite with the hypotenuse, so sine of 55 degrees equals your south direction over 690. Multiply 690 to both sides. Your south direction equals 565.21. And this is just kilometers because I'm finding a distance now because that's what I have on my hypotenuse. To find my west direction, that's the adjacent hypotenuse, so I'm going to say cosine 55 degrees equals the west direction divided by 690. So west equals, if you multiply 690 to both sides, 395.77 kilometers if you calculate that on your calculator. So you might want to practice that, okay? So questions on any of that, please feel free to come find me in the classroom. Okay? The last one, this one gets a little bit tricky. And I know you guys are going to have fun with this in class once I have you do this. But it says a ship travels on a course of 168 degrees for 68 miles. So I'm going to start, this is my starting spot. I'm going to build my crosshairs. 168 degrees course. So that's from due north. So this would be 90. 168 is not quite down. I'm going to go in this direction. Okay. How far did I travel? 68 miles is this distance. And I know that this angle all the way down is 168 degrees. And then what happens is once I get to the spot, I now am going to change direction. So what I want to do is build my crosshairs so I have those parallel lines so I can use those with my transversal going between. And my new course, I'm kind of changing a little bit, 120 degrees. So now I'm going to do this again from the top. There's 90. And I'm going to go another 30 degrees. So this would be a 30 degree angle because the whole thing is 120. And how far am I actually traveling on that one? Another 112 miles. So this down here is 112 miles. And there's my ending spot. And what I want to find is the total distance south and the total distance east. Oh my goodness. Well, what I did, like kind of on the last problem, is once you know how far you're going with an angle, you can find the south and west. You got to do that for both triangles now. Now I want south and east. So what I'm going to do is I'm going to go straight south and then back straight east. So here's my south of the first triangle, east of the first triangle. And then wherever I stopped, I'm now going to do the same thing. South and east. Building right angles. This is south of the second, east of the second. And what you can do now is for each triangle, you can use SOHCAHTOA to find the south vector, the east vector, the south one, and the east one. And then you could add up your south ones to figure out exactly how far south you traveled, and then exactly how far east you traveled. So what you're going to want to do is this. Let's, I should probably kind of draw this in, and that's actually where you're going, but we don't really need to do that. So let's find south of triangle 1. The problem is I need an angle inside. So using a different color, I need to find this guy. Well, it's 168 from due north to my side length. What would the inside be? That just has to be 12 degrees because it needs that up to 180. So once you find that angle, I'm going to do that now. So to find south, that's my cosine with my hypotenuse. So the adjacent hypotenuse, so I'm going to say cosine of 12 degrees equals, and that's going to be south 1 over 68. And then also to find the east, I would say sine of 12 degrees is equal to east 1 over 68. And if you solve for south 1, okay, you should multiply 68 to both sides. South 1 equals the 66.51 miles. And the east of the first one, if you multiply 68 to both sides, east 1 is equal to 14.14 miles. Alright, now let's jump to that other triangle. We need to find an angle inside. Okay, so this is the side I want, and this is the right angle, the other side I want. Can I find this angle at the same spot as that other triangle? Well, my heading was, what, 120 degrees? So why do I write that 30 in there? Is because I went 90 and 30 more. That's 120. Well, what is left over to get straight up and down? Straight up and down is 180. I went 120, so I know that's a 60 degree angle in there. So this isn't going to be too bad at all. Now you could make the connection that this is a 30, 60, 90 triangle, and you could kind of solve for it, but we're not going to deal with that right now. So when it's 112, we want the south one is going to be your what? Adjacent over the hypotenuse again. So I'm going to say I'm going to find south of 2. So cosine 60 degrees equals south 2 over 112. If you make the connection, that's just going to be cut in half. It's going to be relatively easy for you, but multiply them together. S2 will be 56 miles. Okay? And then likewise, to find my east one, I need to find the opposite hypotenuse. So it's going to be sine of 60 degrees equals the east 2 vector over 112. Multiply 112 to both sides. That means east of 2 is going to be about 96.99 miles, essentially 97 miles. And going back to the problem, this is what stinks, is when this takes so long to set up and to calculate, we sometimes forget about what are they actually asking? Total distance south. To find total distance south, you have to add these two up. The south distance of the first one and the south distance of the second one. So 66 plus 56, so south 1 plus south 2. I'm not going to write those numbers in there. I'm just going to say, okay, those two added together are going to be 122.51 miles from what I calculated. And then how far east did I go? I need to find east 1 and east 2. When I add those two together from my work above, I need to add the 14 plus the 96.5. I end up getting 111.13 miles. So that's a way where you can tie everything together on one simple problem. Those are basically all the word problems I'm going to show you. Once again, we will work on a bunch in class. Feel free to come ask me questions at any time. I hope you have a super day.